distributed lidar cache at CISESA. Is that existing or is that proposed future?
No, that is not existing. So and the reason it was not existing is because we do not have a high-speed network. Like if I needed to transfer data from my home to SDSC, and you're talking about terabytes of data, that would take forever. And imagine that with longer. If you're in Mexico and you're transferring that data here, that would take much longer. So that's the advantage of having a high-speed link. The reason we have a partnership with UNAFCO, where they have a distributed data repository right now, is because of the high-speed internet. We're on the Internet 2 system with them. So having this link here would enable that remote repositories.
So there is a 10 gigabit network connection from SDSC to CISESA. Does that provide you the bandwidth, or is there some other location that requires additional upgrades to run at 10 gig to CISESA?
No, I'm not. That's what I was thinking. Like I wasn't aware of this 10 gig network, so we can try out the connection here where we have a repository at CISESA, but I think we need to test out a few things in terms of performance, how data is moving and all that, and we need to do a network analysis to see if it's feasible or if you need a cache here. Regardless, I mean, a 10 gig link should be good enough.
So who would be the point of contact for such bandwidth testing at
we have
SDSC?
People who can test out the network connections.
Yes, who would be the point of contact?
I can be the point of contact. It depends on what data sets you have at CISESA to start initiating this process.
Thank you very much.
Thank you.
I have another question.
Yes.
I will try to speak in English. This time, what is the resolution of the LiDAR images by pixel?
Yeah, so it varies by data sets. So if you actually go to Open Topography and go to data, you can see we have lots of data sets. A quick overview of the metadata, you can actually, it definitely varies per data set. So
my question, sorry, was directly in order to see for El Mayor Cucapá earthquake. My question at the end is, it is possible to see post-seismic deformation if we try to make another LiDAR survey on the area?
Sorry, can you repeat that? If you're talking about if you make another LiDAR survey over the area, you're asking if we can put it into OpenTopo and do comparison analysis. Is that it?
Not only to put, in your experience, what is the resolution of by example, if I want to know the topography of the Mexicali Valley or in some part that will be surveyed by LiDAR, what is the resolution of the vertical, by example, vertical height?
Maybe I'm not that familiar with the geoscience aspects of it because I'm the technical cyber infrastructure guy, but it depends on how you collect the data and what sensor you're using to collect the data. For example, if you look at the LiDAR scan that was flown on the April 4th, the point density here is 9.12 points per meter square. So, and again, the same later, if you have some other LiDAR scan, it depends on who's flying it, which company is flying it, what equipment they're using. So most of them also collect it. It also depends on what spatial coordinates spatial reference system that they're collecting it in. So it varies per data set and by who collects it and what equipment they use.
Okay, thank you very much.
Okay. Sorry if I didn't answer that, but if you send an email to info@opentopography.org with any kind of geoscience questions, we can get the appropriate people to answer.
Hi, I have another question. Can you hear me?
Yes.
My name is Joanne Stock. I'm from Caltech, and I'm curious about how many commercial collectors of LiDAR data there are, and whether you get those data, or whether you're mostly relying on NCOM or specific contracts that people propose that they say we're going to send the data to Open Topography.
So our primary, I can show you the slide I'm working on. Like if you look at our primary, can you see this?
Yes.
So our primary data providers are any NSF projects. So if NSF funds any collections that are, we have an obligation to take it and distribute it to our systems. But we also have a memorandum of understanding with NCOM, the critical zone observatories. So far we haven't had private companies come and ask us, but we did have like the Geosciences Australia come and say, hey, can we test out a data set here? And we do have certain private data sets where PIs who collected, who wrote a grant to collect their data, and they have this embargo period. So within that 6 months, the data set is available through OpenTopo, but it's private, so they can only access that particular data. Yeah, so we haven't had any, I think there were 1 or 2 interests from researchers here and there where they said they had this LiDAR data, they wanted to make it available through OpenTopo. So if it was not, so we have to decide who we say yes to and whether it's NSF funded, because we get a lot of requests from NSF projects, so those are our priorities. Everything else takes a backseat. So one way we address this for private researchers is we have this thing called community contributed data sets. So for example, here, if you look at these yellow dots, these are researchers who asked that their data be available through the Open Topography catalog. So they can register their data sets and we make it searchable. And for example, this particular thing is the Shenandoah LiDAR project. It's ordered by USGS, but it's like a private, like the collector is, it's Ian Rees from William and Mary. So
do you have any difficulty with, for example, if it's somebody who has a laser scanner and a Cessna and they flew it, how hard is it for you to put it on Open Topography? Like, do you get enough information from them for the metadata that it's easy to add it to your database, or would you say it's like not easy and it would be low priority?
It is kind of so metadata has been a huge issue with, well, way back when we started, we were getting all this data from data providers where we had to go back and forth quite a bit on the standard of metadata that was being delivered. So we have a minimum set of requirements saying, sure, they're giving it, nowadays we get it in LAS format, but still there's some issues with the metadata where it's not as good as, or it has some errors where the projection is long, or you get data in 2 different projections and we have to reproject it to 1 single projection or provide on-the-fly conversions. So if you did fly a Cessna plane and you have the data in a standard LAS format, and you had the right metadata with it, it wouldn't be a problem. As long as it's, so our geoscience coordinator determines if it's a relevant fit for open topography. We're looking at strategic data sets, what the importance to the community and all that. So
okay,
it wouldn't be a problem if it's a standard problem format and you have the metadata correct. We could do it in a day. Sure.
Any other questions? Pichu, thanks very much. Thanks for jumping in early for us. It came across real well.
All right, thank you.
Thanks. Luis? Ah, yes, good. I will use, I think, the projector.
Good morning. This is the first time I'm in this nice auditorium. I work in La Paz, southern tip of the peninsula. So in CICESA, but there we have a small campus in that city. I will talk about some study we're doing here at CICESA. I'm a meteorologist, and one of the main problems we have in northwest Mexico during the summer is that we're affected by tropical cyclones during the months of July through October. A year ago, these days, we had a hurricane almost making landfall in the area. This year, the season is different. We had less systems so far. A couple of them affected Mexico recently, and I will briefly talk about that. So the title is Numerical Modeling for Tropical Cyclone Landfall in Mexico. This is work I do with a couple of people from Ensenada for the informatics department and computer department. And this is an example. This is a hurricane that in 2006 affected the state of Sinaloa. Sinaloa is here, and this hurricane came from parallel to the coast in the Pacific, and finally made landfall in mid-October in the mainland. This particular case was important because it's the last, well, it's one of the few strongest Category 3 hurricanes that affected Western Mexico since 1969. 1969, 1970 is the first year when normally we rely on satellites to detect these type of systems. Before that, it was more difficult because sometimes city is not affected or open ocean, there's not much how to detect something happening in those areas. So since 1970, there are satellites that monitor the Earth now maybe every 5 minutes, geostationary satellites. This case resulted in 4 people killed and almost 250,000 affected. And something that is a good index to see how the impact is over the environment, over the population, is the rainfall rate. Hurricanes bring strong winds and heavy rainfall. And here, one particular station recorded up to 300 millimeters. It's about 12 inches in only 3 days. Some of those stations received that amount maybe in 1 year, but sometimes in only 2 or 3 days, the rainfall arrives, and that becomes a problem. It can cause flooding and can cause other problems. This is a summary of landfall areas affected during the last 40 years. What we did here, we looked for each hurricane that went to land and found the point where it crossed the coastline, and that's the definition of landfall. And every yellow circle represents a landfall site. Some of the hurricanes make 2 or 3 times landfall for these purposes. Sometimes it's first in Baja California, then the mainland, and that counts twice. Most of the states affected in the West Coast are the southern part of Baja California, and maybe 1/3 of the Pacific hurricanes going to land, do it through our state, the southern peninsula, and the rest is either the mainland or other states such as Oaxaca and Guerrero later in the season. In the East Coast, the most affected state is in the Yucatan Peninsula, Quintana Roo, which is here. And sometimes it's Quintana Roo, sometimes it's Belize. And the the red plus signs represent the strongest hurricanes. Hurricanes are classified into 5 classes, and the 3rd, 4th, and 5th classes are called major hurricanes, which are the strongest among the hurricane groups. So the ways to study hurricanes, first, satellite since 1970. Then if the hurricane is close enough to land, there are radars and there are weather stations along the coast, but no more than that. And in some cases, few of them for the Eastern Pacific, there are airplanes that go and make measurements. But there are few airplanes, they're expensive, they are not available all the time, and there are other reasons not to have airplanes all the time. So what we do is we use computer systems and we use computer models that run in different systems, either in the Weather Service in the U.S. and in other places in the world. And here at CCS, we're running our particular model to study hurricanes. So that example that you see here, different colors are different models. For that hurricane we saw first, is Hurricane Lane, 2006, and went to Sinaloa. Different colors are different techniques or models. For example, the black line, which is going this way, with gray, it's gray line with black dots. That's the observed track, is where the hurricane center estimated that the center of the storm moved along the life cycle. And the other colors are either other models or other techniques that are available. And the Hurricane Center in the U.S. and the Mexican Weather Service have those models available in real time to make the forecast and try to protect the population or give advance warning as much as possible. And the particular model we're running is H. It means Hurricane Weather Research and Forecast Model. It was released a few years ago by a group of universities and research centers in the U.S. This is an example. This is the same hurricane as before by using this H-WRF model. And what you are seeing there is the white lines are the streamlines, are parallel to the wind direction and near the surface. And in color are the isotags, are the contours with the same values of wind speed. So the red areas are the strongest winds, and this is the center of the storm make a landfall over Sinaloa according to the model. So H-WRF is a numerical model able to predict changes in tropical cyclone structure and intensity over time. And it also considers the ERC interactions, among other things that are good from this model. It has been applied in the operational environment since 2007 by NOAA in the U.S. and started in the Atlantic, then went to the Pacific. It's a model that requires a lot of resources. There's about 500,000 grid points that are used in each simulation. And each grid point is recomputed every either 5, 30, or 45 seconds. So to run a 5-day forecast, we use a lot of resources. And That's when we sometimes have problems, but fortunately, the computer department here at CISESA is helping us to solve those problems. We still have some of them, but are less now than a year ago, 2 years ago. So that's an example. This upper figure represents the geographical area that the model uses. It has a big geographical area going from south of the equator, this yellow line, up to about Canada, and it covers a large portion of the Eastern Pacific, the Atlantic, the Gulf of Mexico, the Caribbean. This particular version of the model is only for the Eastern Pacific hurricanes. And this other figure represents a vertical cross-section that across a hurricane making landfall in the west coast of Mexico. This is about near Puerto Vallarta, more or less, another hurricane moving in the area. So that's output from, we have three computational domains. This is the big one. There are two more nested, movable, moving domains within this big one. Then we have another one. And inside this domain, we have a third domain. The resolutions are 27 kilometers, 9 and 3 for the interior domain. That's the high resolution domain. Is 3 kilometer resolution, 5-second output results. This is a diagram represent. It indicates how we get the data, input data to make the runs. The data comes from NOAA servers in the US. That's the input files. It has temperature, winds, humidity, many of the atmospheric fields that are used by the model to start the runs and make the 5-day predictions. And all those come to CISESA's Telematica site and then to a particular computer in that site. And this is done for some, at this time, it's not in real time, it's only in historical case studies. These are 8 of the cases we run. These are particular times at the time when each hurricane was making landfall either in Baja California, the last 8 years or so, or in the mainland. What you see in colors are the wind speed distributions near the surface or near the ground. In 2008, we had a hurricane that made landfall and affected southern Baja California from the west coast, and it caused problems to part of our state around here. And these are the models I told you before are used to make the operational forecasts. NOAA models that are used all the time. And this is a run. We did that years after the event. And it's difficult to distinguish, but it's not that bad compared with the other models. The difference that is that we run this not in real time. We did that later, but at least it's a test to simulate how things would go in a different environment. This is that hurricane just before landfall. Those are surface streamlines and ice attacks just before going to the peninsula. And a few hours after that, it crossed the peninsula and went to the Gulf of California. Something that you can see is that at first there was weakening from going to the Pacific Ocean to land and re-intensified over the Gulf, which is expected. The Gulf normally, at least in the sense of sea surface temperatures, is warmer than the Pacific side. And this is a particular example of what type of results we're getting from this model. This is about rainfall, perhaps for emergency managers, for the Weather Service. One of the main fields or main output results is to say what will happen with the rainfall rates and the spatial distribution. Most of the deaths in Mexico, in the US, come because of rainfall, not because of the winds. So This is a quick display. This is what the model did for the previous Hurricane Norbert in 2008, the one that made landfall in the west coast of the peninsula. And this is something close to the observations. It's a NASA satellite. It's called TRMM. It's a NASA Japan project that estimates rainfall not only over land, but also over the ocean. The ocean has, at least in the meteorological sense, the problem is that it has no weather stations, or at least boats can report that they are moving, and there are a few of them. So there are some problems, and this particular satellite tries to help in that sense, to estimate over the ocean, over land, or everywhere, near the tropics. The T, I think, is tropical rainfall measurement mission, something like that. And this is a satellite perspective before landfall and going to the mainland of the same hurricane. Something else we do at CCS, at least me in La Paz, I support and help the local government when there are hurricanes approaching the area. We never know when it's going to make landfall or if it will do or not. So there are meetings, days, 1-2 days before the expected landfall or approach, the closest approach. And this is the hurricane that made landfall in 2008. So emergency managers meet, and that was the city manager at that time. And this is last month in early September. There was no landfall, but they were worried about how to protect people, what to do. At the end, nothing happened, but we never know, so need to go to those meetings. This is the current city manager in La Paz. A few weeks ago, we had 2 hurricanes that affected Mexico. First, we had a hurricane making landfall in southwestern Mexico, in the state of Colima, Jalisco. The name was Manuel. It was mid-September, a weekend. And the next day, another hurricane made landfall in the east coast, in Tamaulipas. And the name was Ingrid, from the Atlantic Basin. So both brought large rates of rainfall. There were about at least 150 deaths and over 1.5 million affected so far. That's the current government estimate. And the numbers are changing. Well, not much, but sometimes the next day is slightly different. And Manuel is the Pacific hurricane, this one. I wrote there that Manuel did the first the first warning given to the population was 2 days prior to landfall. That's an important number because, now a lot of the critics, a lot of the questions is, did the Mexican Weather Service provided a good forecast, or at least good in advance for the population to be protected? There are several things that are now being revised. And at least in what I found is that this hurricane was, the first warning came 2 days before landfall. In the case of Ingrid, which is the one in the mid landfall in Tamaulipas in the Gulf of Mexico, the first warning came 4 days in advance. So in that sense, it was not a problem. But the thing now is how the population receives the information, because in the state of Guerrero, for example, there are a lot of communities in mountain ranges. There's a lot of poverty there. There's no internet, perhaps, as we do use here now. And things are different from what we sometimes think or believe was happening. This is that NASA satellite estimate of rainfall for Manuel and Ingrid. At least I took several days before and after landfall. And this is what happened according to the satellite between September 12th and the 20th. The landfalls were about the 15th, 16th of that month. This Acapulco, that one. And there's an indication of that heavy rainfall happened overland, along the coast, and offshore. And that was happening at that time in that area. So I went to see the records, the weather station records, which are difficult to find because I saw large numbers. I saw about 1,000 millimeters several days. One day, the next day, the next day. That seems to be too much, but I think we need to check what happened. But one of the stations reported about 1,000 millimeters in one day, which is 40 inches. That's too much. It could cause flooding. It depends on the watershed and other things. And, well, I told you this before from the government. And over the internet, the government is putting a summary of what happened because of these comments from if the forecasts were given in advance or what happened. Some deaths could be avoided or at least should not be happening. This is a perspective of the tracks. The black lines are the observed tracks, but in color are different models. And the red one is the H-WRF, but not from us. It's from NOAA. It's another version that was run at that time. And you see different models are different in the tracks, but at least all of them gave the idea that something is moving from sea to land somewhere. First landfall was here. Manuel did a second landfall in Sinaloa the next week. And we did our model simulation several days after that, and we're still looking at the output. This is rainfall from our run. At 24 hours after we started, we found that the model indicates heavy rainfall in Guerrero toward Oaxaca, which is one of the most affected areas from the event in the actual records. And 2 days after we started the simulation, we see that continued in that part of the country. So still continue looking at that. Manuel did cross again to the Gulf of California. And unfortunately for us, La Paz is here, I live here, there were several forecasts one day saying, we'll go to your area. And we don't like that for many reasons. It's a problem. It's good if it rains, light, and it's cloudy, but not if it rains too much and there are winds. So, well, it was a problem. I was here, I was not there. And the official forecast is the one coming from the Hurricane Center, going to the public. Fortunately, the Manuel went the other way and made landfall in the mainland. And H-WRF, one of the models that I was showing you from NOAA, did a good job, at least in particular time. Every 6 hours, there's a new forecast that may be different from the one you see now. I still have 2 more slides, and I will finish. This is a summary. What you see there is a perspective for one single day, the day that Manuel made landfall in the mainland in Sinaloa. Manuel is that one there. And this is called water vapor imagery. It indicates areas of the atmosphere where the air is dry, which is the black and pink areas. That's drier air. And the green areas are look in the sky, you will see high elevations of those clouds. So I think if you look at these and other diagrams, other data available at that time, perhaps one reason why Manuel did not go to Baja California and went to the mainland is because there were mid-latitudes, which are systems developing of the western coast of the U.S. That somehow made an influence and changed the track. There are large systems, the hurricane is a smaller system that somehow was affected and finally went to another direction. And that's something else that we will be checking, but at least it's a quick idea with the observations. So tropical cyclones are important things that affect the population, mainly because of rainfall, winds. And there are observational platforms, but one good way to study all these systems are using numerical models. We rely on computer systems. There are large files. It takes a long time to make forecasts. For us, a 5-day forecast, it takes 5 hours. And that's, in operational environment, is too much. It should be 1 hour, 2 hours, 3 hours to be useful to the forecasters, or at least to a weather service in a country that could be affected. But the model that we're testing now is able to provide a high resolution, 3 kilometer in spatial resolution, 5 seconds in time. And well, we're studying now historical cases from the last few years. And future works includes to automate the system, perhaps for the 2014 tropical cyclone season in the Eastern Pacific. But we're also using a similar model. We're testing it now, and we want to provide daily forecasts for Baja California for the winter. Well, we will go the whole year. We hope to start by the end of the year, mainly when there are rainfall events here or other things that happen during the winter and during the spring. And, well, this is funding from the agencies you see there, and also technical support from CICES's computer department. This is the last slide. Same as before, but perhaps yes, that's the idea. The thing is that the Weather Service has preferences, and they want to have things first tested and coming from reliable sources. Now we're not doing that. We're testing our historical cases. But once we do that, we will make that available to the Weather Service and also the general public through a website. The problem now is that we're taking a long time to produce the forecasts. Then when we finish, the next cycle started, because these are updated every 6 hours, so it takes us 5 hours to finish. Just a simulation, but we also need to provide the graphics. It may take one, 2 more hours. So that's the thing we're trying to improve now. But that's the idea. At least the daily forecasts for Baja California that we would like to do this fall and winter, yes, that would be available daily for any user in Ensenada, La Paz, whole Baja California, Northwest Mexico. It's a good model. It's used by many institutions in the U.S. and also in the world. But here in Mexico, we have forecasts for the whole country. The Weather Service in Mexico does that. But we want to do just for Baja California for now. Make a test and verify if the forecasts are good enough or what has to be changed to improve them. Hmm?
Running on
the Baja California forecast, we're testing it. The idea will be run there, here, the Telematica. As he says. Is that your question? Uh-huh. Yes, things are done here. I just connect remotely from La Paz. But everything is done here in Ensenada, the main campus. I think so. Between La Paz and Ensenada? I think so, yes? He said 10. 10 what? 10 megabytes. It takes time. It's slow. Yes, but yes, everything is done here in Ensenada. I just connect remotely from La Paz, and people that help me here work a faster rate than me.
That showed the HWRF servers at NOAA talking to HWRF servers. Is that current?
Well, we bring the input files from NOAA. Let me see, I'm not a computer person perhaps, but I will try to say it. Through FTP. We FTP the files from there to here. How long does it take, Ismael, to bring the input data files? 2 hours, I think. I don't know. 2 hours? Yes, it's 2 hours. It takes time. What happens is we bring, to start the runs, we input files that bring the atmospheric conditions at the time we want to start, plus 5 more or 6 more days in advance. So we bring like a 1 week forecast from the NOAA server to make the runs.
Special, identify a special server on a special address to use
it. I'm sure. Raul, can you help to answer that?
Jose Lozano is the head of the computer department at Telematics, and he is working very close with Dr. Farfan. So I think they are using the link, but they don't need a high speed because only download or use FTP services, and maybe that what we want to try to test is how can we collaborate using the video display wall to share information or I don't know, present the visualization or the simulation results and interact with other peers in maybe the NOAA or something, your contacts for fun. But I don't know. It depends of what you want to do or.
Yes, Jose.
We use a server that is in telematic sites, but it's just an FTP server. And one of the future work that we're working here with Dr. Farfan is to increase the a 10 gig link to his server so he can receive the full 10 gig link capacity that we have right now. So in that case, I exactly don't remember if he, where he download the files, he's using, but some agencies he use the 10 gig link, but on another sites, they use just internet. They are not using internet too, yeah. But we would, in US, yes, in US. But in a few months, we believe we can have also, as the last slide from the presentation, we can have as a backup service or store some of the data that right now is stored in the server in UCD, in SD, in San Diego Supercomputer Center, using the cloud, the storage cloud there. So I don't know if any other question or any other.
¿Otra vez? I will try to respond in English. What happens is every 6 hours, the Hurricane Center in the US makes a forecast. It's called the official forecast. It's given to the public. It's that we see in cartoons and internet and TV. It goes to the emergency managers and everyone. But the official forecast is derived from many sources. One of them are the numerical models, such as H-Worth, the one that I showed, other models from NOAA, other techniques, the statistical techniques. But very important, they also rely on the personal opinion of the forecasters, their experience. So the forecasters meet, like here us, and talk to each other and decide what's the official forecast. So they take into account everything and their experience of what's happening and everything possible, the best they can. And that's done in Miami. When the hurricane is close to make landfall, they decrease that time to 3 hours. Every 3 hours they make the update. It goes to the Mexican Weather Service also. They broadcast to the public. And I think they do the best as they can, and they try to do things as what you mentioned, is use the previous cycle forecast, all the models, everything that is possible. I show you a few of them. I believe there are about 50 different models, numerical models that they use now to choose the official forecast. One. They need to do that every 6 hours. Doesn't matter what. It's like a hospital. And before the time they say, you look, it says 3 p.m. At 2:30 it's ready. They try it. Sometimes it's difficult, like 2 hurricanes at the same time. It's more work. It's the same. It's about 6 people in Miami that do that. Well, there's more support, but 6 are in charge. These are the names you see as responsible. They sign at the end. Well, sorry. What time? I took 30 minutes. Yes, they try to combine opinions and do the best they can and save lives. That's the ultimate objective. Well, thank you. Sorry for the time.
Okay, this final presentation in the geosciences area is from Arnaldo Valle-Levinson at the University of Florida, who I think Salma invited to the workshop, yes. He could not be here with us. He originally intended to present remotely. He wasn't able to do that either, so he sent us a very nice recorded slide presentation, so we know he won't go over time, yes. And the audio is going to come from my laptop, and hopefully they're set up. I'm plugged in. Hopefully it's set up in the back. Just a moment here. Yep. Yep.
Good day. I am Arnoldo Valle Levinson from the University of Florida in Gainesville. I am virtually there with you today to tell you about a research and education initiative that may take advantage of the infrastructure and network provided by the corporation that brings us together here. This initiative that I want to tell you about started from the blowout of the Deepwater Horizon oil platform in April of 2010. As a result of this blowout, the British Petroleum, the company in charge of the oil platform that exploded, dedicated a good amount of money, tremendous amount of money, for research related to oil effects and oil transport in the Gulf of Mexico. And that allowed formation of the Gulf of Mexico Research Initiative. The Gulf of Mexico Research Initiative has funded several consortia that look at different aspects of the oil spill. One of them is the transport processes. And there are 3 consortia that concentrate on transport processes in the Gulf of Mexico. One of them is shown here, the CARTH Consortium, that's based at the University of Miami. Another consortium, the Deep Sea, is based at Florida State University. And a third consortium that concentrates in transport processes in the Gulf of Mexico is based at Texas A&M University. All of these consortia have concentrated in open water, open ocean processes, as is depicted in this figure. This figure shows results of numerical simulations for the oil spill obtained with 4 different models. And the oil spill is supposed to be delimited here or denoted by the black and magenta blotches. The arrows represent the flow field related to the circulation patterns in the Gulf of Mexico, and the colors that you see in the background, the other colors that are not black or magenta, represent the sea surface temperature of the water. But the point here is that the models have concentrated in transport processes in open waters and disregard, for the most part, what happens near the coast. That's very clear in this lower right corner model, in which the coastal areas are in white, meaning that there's no solution for the coastal regions. And as we can see, that the oil spill didn't respect the coastal regions, and actually the oil spill affected mostly coastal regions and created most of the damage in coastal regions where humans live. So the consortia so far have concentrated in mostly open ocean processes and also involved mainly scientists from the US. So on that basis, we have thought of alternatives to that. In addition, the consortia have found out that small-scale processes, what they call sub-mesoscale processes, on the order of a few kilometers to a few meters in length and on the order of hours to seconds in terms of the variability of the motions, are important, as depicted in this diagram of surface drifters moving around in the Gulf of Mexico, depicted by the, deployed by the CARTH consortium. And these trajectories, in addition to show an overall basin-wide circulation structures, they show what, again, are called sub-mesoscale features that need to be understood better. So the consortia that are actually active consider that these sub-mesoscale processes are important. So that's what we want to do as part of a new initiative. We want to concentrate in processes that actually transport the oil or transport anything at the surface to the shoreline region, of the shoreline, as depicted in these figures. And the initiative that I am proposing to start has to do with not only with studying small-scale processes in coastal regions, in particular in estuaries, but also involving the two countries affected by the Gulf of Mexico outside of Cuba, right? So that's the U.S. and Mexico. And the idea is to study estuaries, transport processes in estuaries, that is in very coastal regions. In Florida, so we've identified a few important systems in Florida, 4 or 5, and more in Alabama. Alabama has Mobile Bay, but also colleagues in Alabama could study one of the westernmost estuaries in Florida. We have colleagues also in Mississippi to study Mississippi estuaries, and Louisiana also to study Louisiana estuaries, and Texas to study mostly 3 estuaries. Then we go to Mexico, to the state of Tamaulipas, to study a couple of estuaries, same as in Veracruz, and then one in Tabasco and one in Campeche, and then a couple more in Yucatan. So as you see, there's a good number of estuaries that we want to study with this initiative. In this initiative, we want to concentrate again on small-scale processes, and the initiative, the consortium that we want to propose will be facilitated by XC. I don't know if that's the way you pronounce it, but I'm trying my best here. And this has been facilitated through conversations with Nancy Wilkins-Thier, with Salma Khalife from CUDI, and from colleagues at CICESE. And we want to establish this consortium as part of another round of proposals that will be announced in mid-November. Pre-proposal stage will be due by the beginning of January of next year. So the main purpose of this presentation is to seek any other people interested in participating in this consortium. We have already recognized or identified people from each of these 10 states, 5 in the US, 5 in Florida, that will be in charge of leading the activities in their states. And XSEED will allow the communication and the activities that I will depict in a moment. So we want to study 3 main processes that seem to accumulate materials at the surface, in particular oil. And these 3 processes are called coherent structures. So the first one is related to plume fronts that are formed from the discharge of fresh water, river waters interacting with ocean waters. That creates a convergence zone. That's a coherent structure, accumulates material. So we want to use 4 approaches to study these features, these coherent structures. One is through shipboard measurements, so that would generate gigabytes of data. Then we want to use drifters that would generate megabytes of data. Then we can use dye experiments, dye tracers, to look at the processes that generate these convergence coherent structures. That would generate also gigabytes of data. But the activity that would be most computer intensive would be the elaboration of numerical models to look at these features, and we need models at different scales, at relatively coarse scales, but at very fine scales to be able to resolve the processes that are important to the transport of these floatables at the surface of the ocean. So that would definitely generate terabytes of data. So those are the 4 techniques that we want to apply to study this type of coherent structure, that is the plume fronts. The second coherent structure that we want to study are the along estuary fronts and tidal mixing fronts. And those are produced by the interaction of tidal currents with bathymetry, where there's a very sharp change in bathymetry. There's usually the formation of a front, and that doesn't need different densities in the water. That is, you don't need the interaction of river discharge with ocean waters, but simply the interaction of tidal currents with bathymetric changes will generate these coherent structures that we want to study with the same set of 4 approaches, with shipboard data, drifters data, dive tracers data, and numerical models output. So that also will generate terabytes of data. And finally, we will study wind-driven coherent structures, usually known as Langmuir cells. And for that, we would also use the same approaches of shipboard data and drifter data and dive tracers, as well as numerical models. In this case, we would need very high resolution, very intensive applications of numerical models to be able to resolve these structures. So again, the study of these coherent structures would be facilitated by the infrastructure provided by the corporation that gathers us here. And also the 4 types of data that we're going to be collecting will allow the construction of Lagrangian coherent structures, as depicted in this animation, that shows in relation to the oil spill in 2010, where the oil was most likely to be concentrated and transported along these lines, these coherent lines, calculated with what's called Lyapunov exponents. So the purpose for us would be to generate the Lagrangian coherent structures that would indicate the most likely pathways of oil transport in shallow water. So what we're seeing here is for open waters. We want to take this technology and use it in all the estuaries that I showed earlier. So that's the essence of the project that we want to develop. We're looking for potential collaborators. When we go back, questions that we were asked to address, what are the challenges for network-enabled cross-border research and education collaborations? That would be a big challenge for us, given the tremendous amount of data that we expect to generate, and to be able to share that across the border among scientists of the US and Mexico. That's going to be a big challenge. So that the challenge would be how to transfer the information that we generate at each one of these estuaries. Where can we store the data that we collect so that everybody can access the data in a very efficient and very effective way and quick way? And also, very important for the development and execution of numerical models, we will need high computational efficiency and expediency so that we can run our numerical models at our sites, and also maybe collaboratively with colleagues from other universities, even across the border. The second question that we were asked was related to the cyber infrastructure requirements for science application to work effectively in a cross-border collaborative environment. And so the requirements would be the same as before: to transfer information, where to store the data, to have a computationally efficient infrastructure, but also in addition to carry out educational activities that cross the border too. And finally, the question of how this workshop can help us be more successful in cross-border science and education collaborations. So I think that it's already been successful by providing us this platform to present and exchange ideas on international collaboration. So hopefully we'll have our network expanded for this initiative. Again, research, the call for proposals will appear in a month, mid-November. So we're getting a little bit ahead of the game here so that people start thinking about, how we can improve the ideas that we have set on the table so far. And we have the commitment already of several people at each one of the states that I mentioned. And there's an enthusiasm for collaborate from people at CUDI. And also Nancy has expressed interest, and we are hoping to involve people at CICESE as part of this consortium initiative. So again, my name is Arnoldo Valle Levinson. If you want to contact me, there's my email address, and I look forward to getting some feedback on this. Thank you very much, and have a good day.
So I think it's break time, yes? Yes, good, break time. Okay, return at 11.
Universidad Nacional Autónoma de México. Sí. Universidad Nacional Autónoma de México here in Ensenada. Before entering into discussion, I just wanted to bring you an example what I think big data and big network could be used. First of all, this was a joint collaboration and a joint investigation between different universities. The name is Platinum Atom and Cluster Electrodeposition on Unsupported Carbon Nanonions. The work was performed by experimental part was performed by University of Texas in El Paso, University of Puerto Rico. The experimental part, also the high-resolution transmission electron microscope, was performed by University of Texas San Antonio, group of Professor Yacaman, and CIMAB and ourselves, we did the theoretical part. So what was the involvement that we had? First of all, we did the theoretical part in order to simulate what is called the onion carbon nanostructure. We started doing with a C60 carbon structure, and then we put inside this C60 into another layer of 240 carbons and tested for stability. Unfortunately, it was not stable. Then we had to put a third layer of 540 atoms, carbon atoms, and then we have 840 atoms plus the valence electrons of the carbon in order to simulate what is called the onion-like structure. When the experimental part, the high-resolution experimental part was achieved, they found that the platinum were dispersed in all these layers. And they found that this triad made of platinum, which they measured the distance between one and the other, and they found this number. And also, if we compare the result, the theoretical results is comparable to this one. The 2.8 is a little farther from 2.6, but in between. And the other one is 4.7, 4.7, which means that I wanted to tell you first that we did the theoretical simulation first than the experimental part. So we find out an excellent agreement between these theoretical calculations with the theoretical part with experimental part. So this is a very good example of what we can do if we would have facilities like you are proposing. Also, I would like to tell you that we performed the calculations in a supercomputer in UNAM, but we don't have enough. We need more. This work was appearing last year in Langmuir. Now, let me start with my talk. There is a motivation behind all of this. And first of all, we inquire about the electronic properties of this three-material sandwich, and we would like to see if it works as a catalyst, or if it will work, if it is likely to work as a catalyst. The motivation. Why we are motivated? Well, first of all, we are glad that we are working in a field very competitive, in which in 2010, the Nobel Prize in Physics was awarded to these two people. Second, before entering into discussion, for those of you who are not very well familiar, carbon is the materia prima for life and the basis for all organic chemistry. Also, if for any chances I create an infinite array of hexagonal carbon like the one I have in here, and if for any chances I cut a little piece and allow to rest by itself, the new structure won't be flat. Instead, it will form a ball like this, which is called zero-dimension buckyball. In the second case, if I have this red rectangle and I cut it again, it won't form the fuel ring. Instead, it will form a 1D nanotube. And in the third case, I cut the little blue piece. It will form what is called three-dimensional graphite. Now, if I peel off all of these layers, and I end out with only one, this is what is called graphene. So let me point out a very important thing. We have three different structures. In one half, we have graphene, which we know it has beautiful properties and created a new physics which are producing very interesting results and applications in our daily life. Also, I just wanted to mention that graphene is a zero-gap semiconductor. In the second hand, I have boron nitride. This is the hexagonal form corresponding to graphite, and it can be used as a lubricant and additive to cosmetics. Also, boron nitride is an insulator. The band gap is 5.5 electron volts between the valence and the conduction band, and it is the same as diamond. In the third case, we have the transition metal, the chalcogenides, in which molybdenum disulfide is used as a catalyst in the desulfurization in petroleum refineries. Also, it's used as a lubricant. So we have three different systems. We are going to put them together and try to form a sandwich. What are the electronic properties of this sandwich? This is the question that we wanted to answer. These are the references. So we are going to perform a theoretical calculation. Theoretical calculation, we are going to use a Stender-Huckel tie binding method using a computer program named yet another Stender-Huckel molecular orbital program. And this is a method which is a semi-empirical approach for solving Schrodinger's equation from the non-relativistic point of view and independent of time, in which we consider all the electrons and use the variational theorem in order to solve it. So we started with a supercell for the graphite, in which we use the primitive vectors in the crystalline graphite. This is the space group. Also for molybdenum disulfide, these are the primitive vectors, and this is the space group. And for boron nitride, the atomic positions were obtained in a modeler called nanotube modeler. And then we wanted to do a calculations in this field. Now that we know to start, then we create a supercell and select this small cell of carbon hexagonal array in which these two carbons were replaced by oxygen to create a defect. Then we replace the carbons, and then we get rid of this bond, and then we have a defect. Why we create a defect? Because we have had the experience that from the experimental point of view, if we wanted to locate a molecule at top, the molecule will be located preferentially on the defect. So we are trying to simulate from the real point of view. Then we have the molybdenum.
To the conference.
Then we have the molybdenum on the sulfur.
You are the only participant in the conference.
Oh, I kept this press. Then we have the molybdenum disulfide. Instead of using a crystal, we use a one part of the crystal, which is called 1H, in which we have sulfur, molybdenum, and sulfur. And then we reproduce in the top part, we reproduce the boron nitride, which is with boron and nitride. And this is the sandwich that we are going to simulate. Then, what else we need? We need the wave functions. We are going to solve Schrodinger's equation independent of time, not relativistically. We need the wave functions, and we need the valence electrons of each atom by itself. In this figure, I have the Wigner seed cell for an hexagonal array, which generates the Brillouin. And these are the orbitals for each carbon, and then I have the Huckel parameters that I will use in the wave function. For those of you which are not very familiar, the Huckel parameters are related to ionization potential of the free atom. And then I have in this other part the rest. Before leaving this, I just wanted to show you, this is an aberrated transmission electron microscope aberration corrected micrograph, in which we have a graphene oxide membrane. And look, we have different configuration, and these configurations are related to the defects. But we are concentrating in a defect like this. Now what we want to know, electronic properties are the more interesting that we want to do. So we do band structure calculations. And then in order to do that, in order to do the integrals, perform the integrals, we use 51K points sampling the Federal and so on. We have energy versus K points in the reciprocal space, and then we have a multiple degenerate bands. With the horizontal dotted line, we have the Fermi level, which separates the valence band from the conduction band. And notice it is placed in between these multiple degenerate bands. So we continue, and now we create the defect, and we locate one molybdenum disulfide at the top. And again, the horizontal dotted line is related to the Fermi level. And in the third case, we create the boron nitride at the top in such a way to create a sandwich. And now see that the horizontal dotted line is in between these multiple degenerate bands. In this table, we do the analysis. In first case, we have the graphene. We have the Fermi level just for reference, and we see that we don't have any gap. Hence, it's a semi-metal. In the second case, when we have the defect and we put the molybdenum disulfide at the top, also we have a zero gap, which is a semi-metal. Also, we see that there is a shift on the Fermi level. And in the third case for the sandwich, we find out that the Fermi level has shifted, but also there is a gap of 0.12 electron volts. Hence, we find out a semiconductor for the analysis that we perform. But we wanted to see, mainly we are interested in which orbital from which atoms contributes to the total density of states in the vicinity of the Fermi level. Why the Fermi level? Because the electronic properties are manifested in this place. we did for each case, as I told you before, and we projected, we have the total density of states, this is the solid line, and the hatched line is the projected density of states. I could have known this a priori if I could have done a group theoretical analysis, but I'm confident that the program has this analysis inside, so it can produce it by itself. I do total and projected density of states. So I projected only those orbitals which are close, and I see that the main contributions come from carbon P. In the second case, I have molybdenum disulfide. Then I have in here, the horizontal dotted line is the Fermi level again. I have energy versus percentage of contribution taking into consideration that the biggest graph corresponds to 100%, and these are related to this 100%. And in the second case, I have carbon piece and also sulfur piece. And in the third case, I have a mixture, I have a sandwich. Then I have a contribution coming from carbon, from sulfur, from boron, from nitride. So I am able to find out which orbitals contribute most to this contribution. Also in this table, I have this information. For graphene, only contributes carbon piece with 5%, and this in parentheses is the total. Graphene with defect, 3 and 1, 4%, and for the sandwich is 2 and 2, and just a little less than 1. So I can see that there is an overlap between orbitals, and this overlap forms a very localized hybridized band. Also, we need average charge, Mulliken population analysis, so it's a way to see how charge is distributed. And we select the different atoms within the unit cell, and then we see these changes depending on the configuration. So there is a redistribution of charge depending on the configuration that we wanted to find out. Conclusion, the results obtained yield information about the electronic properties of the material that we have analyzed. First, well, I will tell you that for the first two cases, when I have the molybdenum, when I have the graphene with the defect, when I have the graphene with molybdenum sulfide at the top, and when I have graphene, molybdenum disulfide, and boron nitride, that I call it the sandwich. In the first two cases, the behavior is semi-metal, and for the third case is a semiconductor. In addition, total and projected density tests provide information about the contributions. And in the third case, the overlap using average charge provides an information regarding the distribution from the analyzed configuration. The experimental part of this work is being performed, and we hope to have a correlation between our results and the experimental part. I acknowledge some contributions, and those of you who are not very well familiar, and these are the mathematics that you will find when you solve the Schrodinger's equation. It's not very confusing, but I just wanted to tell you that the basis set is a slightly dark orbital with single for S and P orbitals and double zeta for the orbitals. You have the radial part, you have the spherical harmonic, and you have for the D, you have a combination. And that's it. The experimental part of this investigation on the process at the moment, and thank you very much for your attention. Yes?
You say you use the supercomputer in UNAM in Mexico City. You need, for purposes of remodeling or your process, you have to transfer data. You carry it in an airplane when you are located where? CENIC. So how do you deal with? Through Terminal X? Okay.
Simulate that you are in Mexico City. You do the calculations in Mexico Mexico City, you see the results on the computer. And if for any chance you are satisfied for you have already done, then you can print it. Or you can send your information directly to here, and we can print it in here. So we have access to supercomputing time in Ensenada. This is one of the facilities that we have in here. So we don't have a computer physically, but virtually we have. And we are lucky also because most of the people in Mexico City who wanted to do any kind of research, they had to submit it in a long line. We are lucky because we can do it interactively, and we can see the results immediately. So immediately you wanted to change any parameters, or you wanted to do a similar calculation, or you are not satisfied with the result, you can change it. And you can obtain the results immediately. Because this, the first example that I told you, we have to wait a little longer because the time it was consuming, too much time consuming. But even though we can do the calculations in here.
You are the first participant to join the conference.
Thank you very much. Carlos, you have a question?
Yeah. I imagine this is the type of things that could be facilitated by science gateways, no? Are you aware of the possibility of using, for example, the NanoHub Science Gateway at San Diego Supercomputer Center at EXIT?
I had an idea, but I was aware.
Okay.
We will appreciate it also.
Okay, but I think one of our big issues is how to communicate that these easier ways to use supercomputing facilities is available for Mexican scientists, no? That perhaps could be facilitate the access for more simulations and for more, I don't know, the science gateways in principle try to facilitate the use of supercomputing for scientific applications. No? Good. Thank you.
Almost good afternoon. Thanks so much for the opportunity to be here and to share a little bit about the plans and the projects that the Mexican Space Agency are considering and how these activities will impact on this aspect of big data and big network. Particularly, let me point in this presentation the aspect of data center and data processing facility, and from the national scope, from the national point of view, and involves not only the repository of remote sensing imagery, but also astronomical, astrophysics, space weather, and many other space field data-related aspects. Let me start, and I already apologize for all the colleagues that already see this slide in some other place about the Mexican Space Agency, but just to take in consideration that probably some of our visitors still are not aware about the Mexican Space Agency. That is a new project. We have 1 year and 8 months in operation. And let me spend some slides related with how the Mexican Space Agency is organized and how we are working on what are the plans. Let me start with the Board of Government. The Mexican Space Agency is a federal entity that have in the board 7 ministries, and the head of the board is the Ministry of the Secretary of the Communications and Transport. But also we have the CONACYT, that is the national entity for research funding. The organization that is representative of all the universities in the country, that is the NUIS, but also INEGI, that is an independent entity that is the legal responsible in the country for all the remote sensing data and geographical aspects. But also we have academic, the UNAM and IPN are the 2 major universities are part of the board, and also the 3 major academies, the engineering, the science, and the medicine academy. So we have a very rich board in which we have a good balance between academic, but also priorities about the government. And about priorities, well, let me start that. This is very interesting because not always in Mexico we have the opportunity to first start with a national policy and then create some acting body, that in this case is the agency. We were very lucky that after the law that created the agency, the second step was to write a policy of what are going to be the priorities in terms of space activities in Mexico. And these 13 lines are the key points that in a very democratic sense was enriched by all the sectors in the country. So in a common agree, these are the priorities for the first years of the agency, and are related with many aspects, but let me point the aspect of the scientific research, human capital, international cooperation, funding, of course, but all from the point of view of trying to protect the Mexicans, protect the environment, provide sovereignty and security, and some kind of independence, both in technological and political aspects in terms of autonomy. And this leads, because the third step about the strategy was to write the national program for space activities. That was our very first activity as part of the once that the agency start operations. But this national space program was ruled by 2 main aspects that was defined by Dr. Mendieta, that is the head of the agency. And this was how, using the capabilities that offer the space, we can help to solve national problems and needs, and how we can support the job creation. So these are the 2 main priorities for the space agency, and most of the activities that we are trying to conduct are ruled by these 2 main aspects. And of course, this without forgetting that we need to support also the science, the basic science also, because it's highly important and it's really one of the core aspects in which the country has been contributing the last years related with the space activities. Also, related with this, the collaboration agreements is really important. Already we signed international MOUs with the different space agencies, and this will help to get access to many information and resources in other countries. We already have agreements with the German Space Agency, with the Ukraine Space Agency, Italian, with NASA, and the UK Space Agency, and we are in process to have agreement with Roscosmos and the Indian Space Agency, and also and other entities. As part of the interactions, the collaboration with the states is also very important because the states have a lot of flexibility about funding. And we saw the regional development of the space activities, a key aspect of the National Space Program, and is linked with the support of the states. At the moment, we have 5 states already signed an agreement with us. That is Jalisco, Querétaro, Hidalgo, Yucatán, Puebla. And of course, we are in process to get more states on board of these collaborations. And also, we have already agreements with different institutions in Mexico, UNAM, National Polytechnico, CICESE, UABC, even private companies also, because it's really important. And as I mentioned before, the National Space Program Dr. Mendieta was really worried about to have first a strategy and later build a structure to respond to this strategy. Because normally you have an institution and later you try to accommodate the resources of this institution in order to fulfill one specific activity. In this particular case, we decided to make define a strategy, and after that try to see which kind of resources we need to carry on this strategy on the future. So the core aspects of the National Space Program are in 5 areas. Human capital, that Carlos Duarte is here, is the head of the human capital area. We have space science and technology that I have the honor to lead in the agency. But also we have industrial and commercial development, international affairs and security, and financial and organizational needs. So this is not strange that after the national program, we developed the structure, and the structure truly reflects the attention of one of these areas in the national, in the program of space activities. Let me point now a little bit more about the space science and technology area. The idea is to have 3 core areas that is related with the space technology, space science, and the regional centers, that is the coordination office for all these regional efforts with and collaboration with the states. And pointing a little bit more about the strategies that are reflecting of the National Space Activities Program. That is, in particular in the science and technology, the idea is to support research and innovation on the field of space science and technology for attention of national needs on their sustainable point of view, and to promote the creation of added value for the society. Because all the agencies have this outreach problem that we need to convince the people the importance to invest not only in the space science and technology, but in general in science, in order for them to see the true value that this produces in the society. And we have these are some kind of particular activities that are related with the line actions that are on the plan. Let me point particularly that we are going to write a new plan because by law, starting a new administration involves the creation of a national development plan, then a sectoral plan that is for the Ministry of Communications and Transport. And this, by law, obligate to us to write a new national space activity program that needs to be aligned with the new priorities of this new federal administration. But still we are working. The main aspects are not going to change too much because already we have been involved in the process to write the National Development Plan and the sectoral fund plan. And so the idea is that we are trying to put everything, all the pieces, keep on the same track, more or less, And particularly, let me point this, that is one of the main programs, main lane actions that we put in the National Activities Program was the development of an early warning system for management of natural and man-made disasters and to support these activities. We were lucky because at the end, we managed to put this as an action line on the National Development Plan. And this is truly, truly important because it's the key aspect in order to get funding to support all these activities under the federal government. But to develop all these line actions, we have a lot of challenge, and these challenges are both economic and organizational. And all these challenges are taken in account on these action lines in order to try to fulfill the programs according to our realities. From the economic point of view, it's time and cost of the projects. Normally, it's long time to develop space projects. The government and sole source of funding, because normally all these projects depends and rely on having a proper federal support. Of course, we are trying to find innovating ways to support and fund in all these projects, private-public partnership, for example. The necessities, many of the aspects in the country are ruling for necessities and probably a short-time vision. And the idea here is to plan for the 20, 30 years in advance. We can take the example of China that they were talking about the space and many of the activities that the planning is for 100 years in advance. So they are planning now for the next 100 years. So this is an impressive way to have a long-term vision of what do you want to achieve on the future. From the organizational point of view, one of the key aspects is that we need to work more in the management and the project management skills. System engineering are probably the two main areas in which our projects need to be very careful in order to be successful for the future. Lucky for us, we have been working and trying to establish policies for long term and change the perception of the social impact that the research activities can produce on the country. And from that point of view, we try to motivate a change of paradigm. We try to change the view in which the space assets are perceived on the common population. And the idea is to have the concept of a space infrastructure. The idea is to convince that all the space assets are combined with the space infrastructure in terms that, and the same relevance that the bridges, ports, airports, etc. And we were lucky to put this as part of a new concept. It's going to be reflected on the sectoral fund as part of the infrastructure that address the Ministry of Communications and Transport. And the strategy was to try to reflect all this space infrastructure and early warning system on the National Development Plan. We were successful. On the National Infrastructure Plan, also we are being successful. And now the board also give the approval to request the funding for these projects. That this project, that is the early warning system, considered to have 2 satellites as a space infrastructure on one of medium resolution and one of high resolution. But the most important part for this topic is how to solve this and how it's going to be related with the big data and big network. Let me address that the disaster management in Mexico is involved with several entities. Some of these entities address the problem of early warning, some others address the relief of disasters, some others the remediation. And the challenge are communications, coordination, and timing of the information. And so the idea is, as part of this national infrastructure of the early warning system, the idea is to have a national system for storage and data processing for geomatic space and astrophysics information. but also support the development of connectivity and applications. And what we are talking about this, the idea is to have a state-of-the-art storage facility with backup. By law, we need to, many of the remote sensing data that the federal government needs to use need to be in Mexican territory. So, and this is a consideration in order to have this. Considering many projects that are running now, the data flow is probably more than 1.5 petabytes per year, probably even more if we were successful in getting more projects. But also we need to develop a data processing facility in order to produce products for several entities, initially for the government, federal, state, and municipal. And a very, very key aspect is the connectivity between the main users, initially federal ministries, but the idea is to connect all the entities that are involved on produce these results and these products that are going to be used. And this is more or less the picture of the space infrastructure. You can see here the two satellites. We are going to have a ground segment to get all the remote sensing data. Probably we were able to use another satellites from other sources, but the idea is to have this high-performance national storage system in order to provide information, using the connectivity, provide access to another facilities, but also to a data processing facility. The idea is to get the support from the states in order to put these facilities in different states in Mexico and provide the connectivity for them. But also we need to have the communications aspect, and for that we are going to use, we are going to rely on the new MEXSAT system. That is the satellite that involves L-band communications and fixed communications, but it's not going to be enough. So the idea is to try to propose new communication satellites using upper bands, like A-band, for example, and use these because we have all these slots in which we can use, because these slots are not good for making business because they don't see all the, in a continental, don't have a continental view, but have a partial view of Mexico. For example, with this, you can put one satellite here and one here, and you have half of the country covered by this and half of the country covered by this. So with two satellites, you can provide high band data bandwidth coverage to all the country in upper bands, for example. So it's also part of the idea to develop this. But also we want to support the space and activities, and for this we are established a trust with CONACYT in order to dedicate the funding for space projects. It's going to be a sectoral fund in which normally the idea is to put money there, and CONACYT equally. This is one to one. And the idea is to also to get the regional development support by the states via the FOMIX, that is called Fondos Mixtos in Mexico, that is the effort from the states in order to support projects, and of course international collaboration in order to this. As a summary, the space infrastructure is a change of vision for us, and this will open the door for getting funding from the infrastructure plan. And we have a big data problem associated with the use of the space infrastructure. So the idea, from our point of view, is to develop all the infrastructure that the country needs as part of the space infrastructure that we call it, to manage all this enormous flow of data from remote sensing, astrophysics, astronomical, and space weather activities in the country. And the idea for this starting times is capacity building. And our early warning system is the big project in which many parts of the space infrastructure that we want to build for the next years are rely and based on this project. Thank you so much. aquí toca yo el micrófono.
You talk about collaboration with many many institutions. I would like to know with academic institutions, what is the relationship you're going to have, particularly on the processing and the recollection of data and storage. Is it going to be public data, or you have, I don't know, data that is sensitive?
Yes, we have both. You know, even yesterday we were discussing about the open cloud, for example. That is an excellent vision on how to share and how to storage public data. We are considering that we are going to have remote sensing data and astronomical data probably that is going to be public and is going to support research activities that are public by nature. But also we are going to have sensitive data that is going to be stored in a different way, in a different place. We, as a Mexican Space Agency, we are a coordinating body. We are not going to have the resources to do by ourselves any of the research activities that the country needs. So we are going to rely on all the scientific and research and universities on the country to do the things, very similar to the scheme that UK Space Agency or NASA follows in order to distribute all the job, distribute the money. The idea is to put together money, problems, and technology, and we coordinate the efforts, but the idea is that all these entities are going to do the job. The very first example of how it's going to work this is we have an antenna in Chetumal that is receiving remote sensing data from DLR satellites principal. And this facility is in Ecosur, that is a research center similar to CICESE, and is involved on the operation of this INEGI, CONABIO, and the Ecosur, and I think that I miss, and of course CONACYT is supporting the activities. So the idea is initially provide high bandwidth connectivity, the fiber, even we request to Carlos and CUDI this connectivity. And they are going to work everything, the processing, the manipulation, the distribution. And the idea for us is just to support, provide the facilities for them in order to be able to do better work. We want to provide the technology and the support in terms of funding to have a better space infrastructure. But the idea is to rely on these institutions to do all the job.
With regards to the space image repository, is this a collaboration that you're going to have internationally, or this is only a Mexican?
Well, we need to address both, and this is, we are going to ask to CUDI to do this research for us, because as you are the specialist, we are requesting to CUDI to do the analysis in terms of the national perspective, which plan is the best for us. But considering these two aspects, that we are going to have public information that could be accessible for everyone, but also to consider to have some data centers, some links in a private way in order to manage all the sensitive information that is going to be related with the high-resolution imagery principle for other applications that the country needs also. Thank you so much.
Hi, good afternoon. Before the slides show up, I'd just like to thank the organizers for giving us the chance to present what I'm going to present here. A lot of this is going to be Okay, so a lot of this, part of this is going to be historical because we're talking about big data, big networks, but we haven't always had that. So where we started from, well, I suppose I should, I'm head of the National Optical Astronomy Observatory, whose headquarters are here just down the hill in Ensenada. Whoops. And the observatory itself is located 150 kilometers south and 100 kilometers from the Pacific coast towards, well, halfway to the Gulf of California, more or less in the middle of nowhere. It's basically a small town of 20 to 25 people that nowadays takes about 4.5 hours to get there from here. Everything has to be brought in, food, water. Mexico is the greatest per capita consumer of Coca-Cola in the world, and the nearest Coke vending machine is 60 kilometers from the observatory. That gives you an idea of just how remote it is. The observatory generates its own power, and our connection to the outside world today is via a microwave internet link. This is how it started with, on the right side of the photograph, you see the satellite antenna. It's not really pointing at the rock, but just slightly above it. And on the left side, you see the high-tech equipment that was used at the time, in the early 90s. The bandwidth was 64 kilobits per second initially, and that included half duplex telephone service. A few years later, it was doubled to 128K and full duplex telephone service. Since 2003, we've had a microwave link that was installed by Telenor, and the bandwidth until now is 2 megabits per second. So you can imagine that at the time, this was a complete change of how we saw the world from San Pedro Martir. It also included voice over IP telephone service. And here's one of the reintroduced condors sitting on top of the antenna. What the condor sees is this. The antenna is not really pointing at the mountain in front, but just above it. Basically, the use is divided into two categories between intensive and light use. Light use is basically general use in telephone service. The intensive use is for data transmission. At the moment, there's only one instrument that heavily uses data transmission, but it basically produces enough data to occupy the full bandwidth for of order 10 or 12 hours a day. And the RATIR instrument that's involved here is a collaboration between UNAM, University of California, Arizona State University, and NASA Goddard Space Flight Center. So it's an international collaboration, and that is basically the route that the observatory development is going. These are other projects that are either well, this is more on RATIR. It's a 4-channel imager with 2 visual channels and 2 infrared channels. It is attached to a robotic telescope, and the data volume is about 22 gigabytes a night. The data are sent initially to Ensenada, and then from Ensenada to the different centers in Mexico City and in California and Arizona. Now, sending the data would be impossible without compression. And with compression, it takes about 10 to 12 hours a day. So basically, we can't contemplate a significantly larger data volume than what we're dealing with at the moment without a better system to get the data off the mountain. Within the next few months, the 2 megabit per second link is going to be upgraded to 10, and that will take us for a couple of years. At the moment, under construction, we have the Taos 2 project, which is a collaboration with the ASIA institution in Taiwan and the Harvard-Smithsonian Center for Astrophysics. There are 3 robotic telescopes with advanced cameras that are going to have basically frame rate acquisitions of 20 hertz. The data volume per night is going to be around 4 terabytes. To get that off the mountain by transmission will require a fiber optic link. It's equivalent to about 410 megabits a second for 24 hours. Next year, we expect the Butas 5 project to be built. That's going to be another robotic telescope with a wide field camera and a lot of high cadence imaging. High cadence being of order a couple or 3 images per minute. We expect that to generate about 35 gigabytes a night. It'll be feasible to get that off the mountain to Ensenada and eventually to Spain, who are the main collaborators here, with the upgraded microwave link and using data compression. Starting in 2015, we expect to have another project come online with French collaborators, which is a flash. A flash is what the project is called. It's a combined satellite and ground-based observing project where basically the satellite is detecting gamma ray bursts, which are only visible from above the Earth's atmosphere, and basically radioing the positions more or less in real time to a dedicated ground-based, well, there are going to be a pair of ground-based telescopes, one in San Pedro Martir and the other in China. And the idea is to have it's going to be similar instrumentation as Ratir. So that's going to be, again, about 25 gigabytes of data a night. Again, it will probably be feasible to run Flash, Butas, and Ratir with the upgraded microwave link, but it's going to be getting saturated by then. We're hoping that by next year we'll start the San Pedro Martir Telescope project, which is a project in collaboration with the National Institute for Astronomy, Optics, and Electronics in Puebla, and various American partners, principally the Harvard-Smithsonian Center for Astrophysics and the University of Arizona, but is probably going to involve the University of California as well, to build a 6.5-meter telescope with advanced instrumentation in San Pedro Martir. Initially, the first generation instruments are going to be generating of order 30 to 50 gigabytes a night, but by the time the second generation instruments come online, that will go up by at least an order of magnitude. So that will probably require a fiber optic link to get started. And by the time the second generation instruments come online, we're going to need a fiber optic link that exceeds a gigabit per second. One future project that could come to San Pedro Martir is the Cherenkov telescope array, which is a collaboration between Mexican, European, and American partners. It's an array of 25 telescopes. Each observation generates about 10 terabytes of data, and there are multiple observations per night. Most of that data is going to get reduced on site, and only the final data products shipped off site, but it will still require a fiber optic link, at least a gigabit, but probably more like 10 gigabits. So how are we confronting this? Well, at the moment we're working with the National Electricity Company to build an electricity line to connect San Pedro Martir to the outside world, and obviously we're going to piggyback on that fiber optic link. The initial plan for the fiber optic link is basically the initial specification is 100 megabits per second, but that can be upgraded. And as Taos will actually need something like 410 megabits per second just to get its data off in a day. At the moment, so that gets us data to Ensenada. From Ensenada, we have to get it to the world. At the moment, UNAM in Ensenada shares a 10 gigabit link with CICESE that connects to Tijuana and San Diego, depending on whether it's international or national traffic. And this will be very important for the instruments that are coming online in San Pedro Martir, but it's also important now for the theoretical astronomers who work in Ensenada. Most of the theoretical astronomers in Ensenada work on gravitational interactions between, well, either cosmology simulations or galaxy structure calculations. And these are not as complicated as the quantum mechanical calculations that we heard about a while back. But there are many more particles. I mean, there we're talking about at least 1 million particles for a sort of run-of-the-mill sort of calculation to between hundreds of million and 1 billion particles for the more advanced ones. And mostly, the theoretical astronomers would like to get hold of the supercomputers in Mexico City or nearby if possible. The main bottleneck for that at the moment is that a lot of the intermediate calculations have to be shipped back. And the connectivity between here and central Mexico is not what it needs to be for that to happen. So basically, a link like what exists between here and Tijuana is a good start, but we need to extend that more to central Mexico, and I think that's where CUDI is going to come in. So that's basically, I think that's the end of it, yes. That's basically what I had to say about our connectivity needs and network needs. Thank you. Yes?
All of the estimates that I heard seem very low from my knowledge of other astronomy locations. And I'm wondering if you shouldn't be shooting for a lot more bandwidth, especially if you can get fiber from the electric company and light it yourself. Like, why limit yourself so much?
Well, at the moment, that's just an initial specification. Apparently, from what my understanding is that basically changing the equipment at the end of the line, you can increase your bandwidth significantly without actually upgrading the hardware. Now, the reason for having the 100 megabit per second figure in there is that this is a project that started several years back. And with the National Electricity Company, changing things as you go is a good way of getting your project stalled. So basically, it seems like a more profitable way of dealing with this is to stick with the original specification, but keep in mind that essentially at the end of the project, we're going to be upgrading the terminal equipment that connect to each end of the fiber optic line. It's true that, I mean, as I say, the second generation instruments are going to generate significantly more data volume. It's going to be closer to in the ballpark of 250 to 500 gigabytes a night. So it's going to increase significantly, and that will require that we have better or higher capacity terminal equipment on this fiber optic link.
Okay, so I totally understand your reasoning of not going back to the electric company and getting stalled. On the other hand, maybe just for the report from this workshop, which is going to be a document available to the funding agencies, you might consider.
Okay, I can up the figure.
Okay. Up to you, okay.
Okay.
Any other questions? Well, here, I'm standing down.
Yeah.
The telescopes that you listed there under future,
yeah,
have those already been approved for funding?
Well, Taos is under construction at the moment. Construction started a couple of weeks ago.
Okay, and let's take Taos for example. Has funding been provided as well for the fiber optic link?
No, well, yes, the fiber optic link is part of this planning process that we're underway with the National Electricity Company.
Okay.
Yes.
So you will actually be able to get that that instrument
Yes.
connected to the CUDI network?
Well, that's our hope. Initially, the plan was initially to basically just shuttle hard disks, which is obviously a very non-optimal solution. But with this, if the fiber link is there in time, the problem is we're at the moment working in the planning stages for this electricity line. I suspect it'll be 2015 before there's any power going over that line. And we expect to have TAOS online, at least the first telescope, by the end of next year. So the match is not optimal, but maybe not too bad. But basically, the idea is now that probably if we have to shuttle hard disks, they'll only come as far as Ensenada and then use the existing 10 megabit or 10 gigabit link to get the data to San Diego and the rest of the world.
Okay. And the data repository, will it be here in CICESE?
Well, we hope it's going to be in the Institute of Astronomy's facilities here in Ensenada.
In Ensenada,
yeah.
Okay. And then the other telescopes you have listed there on the futures, those are planned. They have not been approved for funding yet?
Well, Butis 5 and Flash have funding. The San Pedro Martir telescope, we're working on that at the moment.
Okay. Okay, thank you.
The Cherenkov telescope array, that doesn't really depend on us. That's an independent European, primarily European organization that's developing this observatory. And I don't think they have, well, they certainly don't have full funding yet.
Okay. Thank you.
Yeah.
It's my understanding that there's geophysical equipment up in the area of the observatory, the seismometer and GPS receivers. So I'm just curious whether they don't have nearly as great transmission needs, but is there coordination going on so that their data can also get transmitted with this fiber optic link once it gets established?
Yeah, well, we actually host geophysical equipment for both CICESE and the Geophysical Institute at UNAM. And both of them use our current microwave link to ship their data out. So basically, yeah, that's taken care of.
You mentioned that the theoretical astronomers here at the Institute are using basically data that is hosted where? In Mexico City, in the supercomputer centers of UNAM, or?
Well, actually, what they do is they calculate their models. But since what they're interested in is time evolution of the universe or a galaxy or something like that, they need all of the time snapshots from their model to do their analyses. So actually, they generate the computer models and so on in Mexico City. Well, actually, they don't anymore because they do it locally because they can't basically get the data transferred fast enough from Mexico City to Ensenada. But basically what they would like to do is use supercomputers in Mexico City to calculate the models at each instant in time and ship all of these time snapshots back to Ensenada. So it's a lot of data at a lot of time steps.
Have you explored the possibility of running those models, for example, at the San Diego Supercomputer Center?
I don't know. I'm not a theoretical astronomer. I don't think so. I know they've tried in Mexico City, and I think they also tried using a computing center in Zacatecas, but I don't think they've tried San Diego.
Okay, because that's certainly a possibility that we could explore.
Yeah, that would be worth exploring. Okay, well, thank you.
remarks section, so I will address some closing remarks before we adjourn. So, first I'd like to thank all the participants here of the workshop. I'd like to start off with the speakers. Thank you all for making the journey here to Ensenada, those from the United States and those here in Mexico. It's been a great experience for me, and I'm sure also for the program committee and the stakeholders to listen to your talks. We enjoyed very much reading your abstracts and having you help us in this journey in enhancing cross-border collaboration. So I want to thank you all for your involvement with the workshop, and it won't end here. As I've been saying and others have echoed as well, we will need your help as well with the report, and hopefully that will be a document that will serve your interest as well. So thank you very much. I also would like to thank the stakeholders of the workshop, the National Science Foundation. They have provided funding for the workshop, and they have been a stakeholder and supporter of the AMLITE project and the collaboration between the United States and Mexico. To our host, CICESE, to CENIC, to CUDI and CalIT2. This workshop was conceived by every one of these stakeholders and also built upon the long-standing collaboration between CalIT2 and CICESE. And we hope that this will continue in that fashion, and we'll see some fruits of our labors in terms of better supporting the research and education activities between California and Mexico and the U.S. and Mexico. I would like to emphasize our thanks to CICESE for hosting us. The facilities have been excellent. The auditorium, the video conferencing, the wireless, everything has been really fantastic. So I want to thank you for all of your efforts. It's been great being here, Raul and your team. Thank you very much for your help, and I'd like to give them a thanks of applause. And I also want to recognize the program committee members and the report writing committee members. If you all are on that committee, would you please stand? I'd like you to at least be recognized by everyone here. You've done a great job in helping and coordinating everything here, so thank you very much. And our work is not done. We'll continue. And finally, I'd like to recognize one person who did not join us here, but was really a key and critical resource in helping us develop this workshop, and that is Janice Cortese of CENIC, and she helped with the website, a lot of the documents, and everything on the Google Drive to make this a really effective process. So, oh, she's listening to this? All right. It doesn't surprise me. You know, Janice just pops up, you know, from the ether. All right, great. Thank you. All right, so I have nothing further to say. I will stop here. Raul, would you like to say something? Carlos? Or oh, yes, Greg, come on up. Greg has an announcement also, yes. I was going to let you finish this off, Greg.
I just have a brief announcement that there will be a follow-on workshop at UCSD in February. Tentative dates at this point are the 10th and the 11th. Everybody in this room, everybody registered to this workshop will be receiving an invitation. And we will have more presentations on cross-border collaboration with some hands-on show and tell and see and use advanced visualization technology, which is enabled by the high-speed networking capabilities. And hopefully we'll have some, we'll show you how to use the technology and give you an overview of what you would need to put together the displays in your location and use them with the middleware tools to have distributed collaboration across institutions. So that will be the show and tell goal, training goals, educational goals of the workshop at Cal IT 2 in February at UCSD. Right, so the workshop will also be advertised in the report as well, and to mesh with the goals of the report and this workshop, which is to improve or increase the usage of high-speed networking, advanced visualization tools in support of cross-border scientific collaboration. Thank you.
All right, so some final logistical things. So as far as transportation, it's already outside. So for the group that's leaving to San Diego in... We have 3 people on the list. Okay. And the departure is now? Okay, so they're ready to go whenever you all are. And then the report writing committee, we're going to take a walk to another building. Okay, and we'll follow Raul for that. And then we'll have our transportation scheduled for 3 o'clock. Okay, perfect. Thank you all very much.